All right, so welcome for another lesson. Today's objective again is going to be I will be determining the effects of a graph of the parent function f of x equals 2x squared. So we're still talking about those quadratic transformations. All right, so this first transformations right here, we're always going to start with our home, which we said was f of x equals x squared. I know we're used to using y, but we're just going to go ahead and use f of x because that's the more formal way to do so. All right. So in our first transformation, we're going to describe the transformations that's happening here just from our view. So the first one we have is f of x equals 5 times x minus 3 squared plus 2. So I know I'm starting at home and I want to compare it to my vertex. And I notice a couple of things here. First thing that I notice after I draw my picture here is that I went up and I went to the right. But notice too, my graph, it got a little bit skinnier, right? And we're talked about because when we get a little skinnier, that we're not stretching out. Because if I was stretching out, I'd be getting wide. Think about when you stretch your arms, right? When you're tired, you stretch out and your arms go out wider and wider and wider. Well, in this case, I'm compressing, all right, because I'm getting smaller. So right now, I can circle one of the transformations that I see that it compressed. It got smaller. All right. So this purple to the black, it got smaller. The other thing that I can notate is that from home, I went to the right. So I'm going to go ahead and circle that I also went to the right. And when after I went right, I went up. So think about this as like directions to the store. Okay. The reflection is still facing the same way. So I did not reflect. So we're going to say no, there was no reflection here. If I was reflecting, think about looking in the mirror, it will be in the opposite way. Let's look at example number 2. Describe the transformation of f of x. So instead of this 5, I'm going to turn it to negative 1/2. Then I still have x minus 3 squared and a plus 2. There's a few things we have to notice here. From my vertex to my vertex, I can say I went up and to the right. So we're going to go ahead and circle that. We are going up. We are going to the right. But notice I'm a little bit bigger. It's a little wider. And how we would describe something a little wider is stretching out, just like if we were stretching out our arms. So we're going to describe this one as a stretch. So when we draw this, we know that we went up to the right. So I'm just going to draw myself a little new vertex here. And I'm going to make myself a little bit wider. Is it going to be perfect? No. I'm not asking yours to be perfect either. Just so you know, that is stretching for this example. All right. Now you're going to try. I want you to go ahead and try these 2 examples, and then we'll continue on with this video. All right, so here we go. Now we're on the next part of our transformations. This time, we're not going to draw our graph. We're just going to describe the transformations as so. Let's look at our first one. If we're starting from our home, let's erase this out. We have negative 2 times x minus 5 squared plus 3. All right, so here we go. As I can see from my vertex to vertex, I'm going up and to the right. So I can already circle up and right. And as I notice, I got a little bit skinnier. Not a whole lot, but I got a little bit skinnier. So we can say that this compressed. The reason why we know something compresses or stretches is because our A has a value. And our A at this value is a 2. Notice when we have a whole number, numbers that are 1 or greater, we're always going to compress. Anytime we have a number that is less than 1, like a fraction, we're going to stretch. That's just a quick little tip. Now, the negative does not count as one of the numbers being less than 1 or more than 1. This negative actually is what affects a reflection. So in this case, I started happy and I turned sad. Anytime I go from happy to sad, that is a reflection. So we're going to say yes, there was a reflection here. We're not done with that first example. Let's look at the next one. This one says I have 3x minus 2 squared, and I'm going to subtract 4. So as we can see, from my vertex to vertex, I went down and to the right. So that's what I'm going to circle. I'm going to circle down and to the right. Notice I did get skinnier, so that means we compressed. Reflection. I'm still happy, so I have a happy face and I stayed a happy face. So no, there's no reflection here. That's the easiest way to think about a reflection. Did the face change? Did we go from happy to sad, or did we stay happy? Okay, let's look at our last example. 8 times x minus 3 squared plus 2. As I go from vertex to vertex, I can see I went up and to the right. So let's go ahead and notate that. Up and to the right. I definitely can see I got really skinny. So the bigger the number gets, the skinnier that I get. So this also compressed. And I'm still happy, happy and happy. So there's no reflection here. Awesome. All right. So I want you to go ahead and try these examples on your own, and we'll come back and check for you. All right. So you guys learned a great lesson today. You're going to keep trying examples from here. I'll see you next time for another great video.